plus 2035. All right. Okay. Let's see how we did. What is your inverse? X minus 2 over 3. All right. How do I prove that two things are inverses of each other? Yeah, plug them into each other and show they undo each other, giving you x. So f of f inverse, that's f inverse into f, yeah? So there's f, and in goes f inverse. What goes away first, the 2 or the 3? The 3, then x minus 2 plus 2 is indeed x. So looks good there. F inverse composed on f is take f inverse and plug in f. What goes away first there, the 2 or the 3? The 2, and that does indeed come out to be x. They are indeed inverses. All right, cool. Today's lesson is a good one and an important one. And here we go. You will need a calculator later, but not for a while. It is area between a curve and the x-axis. You could call it areas part 1 or 2. Tomorrow will be areas part 2. So, it might feel like we've already done areas. Isn't that, we've been doing that forever? And, yeah, sort of. If I said, what's the difference between the integral from 0 to 2 of x squared minus 2x, and the question, find the area between the x-axis and x squared minus 2x, it might seem like they are similar. Let's graph, however. Oops. I'm probably going to need this over here. What do you know about that graph? Maggie, what do you know about that graph, kid? This graph. Help her out, Martin. It's a parabola with what kind of characteristics, Andy?
Shifting length.
Okay, so wouldn't, I think we could all agree that factored form would be a natural here rather than complete the square, and so the zeros are 0 and 2, yeah? So, with that picture then, we could get into the question. There's a similarity and a difference. Now, when I say, hey, integrate this bad boy, the integral, the definite integral, comes from the whole idea of area, but this is, integrals are signed area. We often use integrals to describe movement, for example. And I want that negative to show up because it tells me it went backwards. Negatives can also mean lots of other things where negative tells me something. So when I do definite integrals, I allow negatives. Negatives are good. Negatives can tell me something. Negative is okay if it comes out. In this case, I think you'll agree that when I integrate this, I will get a negative, yeah? Let's integrate it. What is the antiderivative? 1/3 x cubed minus x squared from 0 to 2. When I evaluate it at 2, I get 8/3 minus 4. Minus evaluating at 0 is 0. And what is 8/3 minus 4? -4/3. Now that's fine, and that is the answer to the integral problem. -4/3 is your answer. That said, however, that's a little different than today's question is find the area. And when they say find the area, it's more like a geometric area. And geometric area should come out positive. Now there's a right way to go about that and a wrong way to go about that. The wrong way, amateur hour, is just to get out the eraser and say, no, pretend that negative's not there. That's not the way it's done. The correct way is to say, I know, just looking at it, before I start the picture or the integral, that I will actually need to take the opposite because the y's are negative. And so I would start by setting up a positive answer. Please write yourself a note. Do not just erase the negative. All right. So if I said find the area, then it would be more like setting up the integral from 0 to 2, and I would throw a negative out front because I am saying those y values or the heights of those rectangles are negative. I need to make them positive, so I'm going to negate the y values. Then I think you'll agree that later on when I get a -4/3, the negative will eventually knock it out. And the area enclosed is 4. So definite intervals, negatives are fine. But if it says find the area, then take steps to make a positive area. That's the big idea of the day. Now it's time to practice. All right. Say I gave you, this is sometimes the case, that instead of having one region, you have two here. Find the area between y equals e to the x minus 1 and the x-axis on the interval -2 to 2. Give me a nice graph that only goes about 2 wide in each direction is all I need to show. What do you know about graph e to the x minus 1? It has a what kind of asymptote? Horizontal asymptote where? 1? -1, that's still not an asymptote? Okay, y equals -1. Now we're talking, that's an asymptote. Okay, what is the y-intercept? What's the normal y-intercept of e to the x? 0, so now what is it? Sorry, what's the I didn't listen to you, I should have said no. What is the normal y-intercept of a normal e to the x curve? 0, 1, and now it's going to be shifted down 1, so it'll be 0, 0. So the curve e to the x would look something like that, yeah? Now they're asking for us to find the area between the curve and the x-axis on the interval -2 to 2. Now over here, the area between the curve and the x-axis lies above the e curve. But over here, the area lies below the e curve. If there are two regions, you will have to use two integrals. If I do just one integral from -2 to 2, I will get net area, not total area. And I don't want net area, I want total area enclosed. So the first integral is from what left bound to what right bound, please? -2 to 0 of e to the x minus 1 with respect to x, but that area will come out negative, so I need to negate that so it doesn't. Now I could leave the negative out front, or I could bring it in and negate 1 minus e to the x instead. Either one's fine. Very cool. The other region is from 0 to 2, and it's e to the x minus 1, but I don't need to do any negative on that because it is above the x. That's going to come out positive anyway. Follow me? All right. What is the antiderivative of e to the x minus 1? E to the x minus x from negative 2 to 0, and e to the x minus x from 0 to 2. Cool. When I substitute in 0, that's just 0, right? No. I baited you. Okay? It is very tempting for people to say, oh, when 0 goes on, you don't have to think about that, because that's nothing. Not true. There are many functions that when you put 0 in, you get something. Give me 2. E to the x is 1. What else? X plus 2. Cosine of x. Does that come out 0? It does not. Take the time to put in the 0. Oops. So when you put in 0, you get e to the 0 minus 0. And when you put in negative 2, you get e to the negative 2 minus negative 2 or plus 2. All that's the fundamental theorem with the negative out front. You follow? All right, now the fundamental theorem with 2 and 0. That's e squared minus 2 minus e to the 0 minus 0. Be careful and neat with your fundamental theorem, and you will not make a mistake. All right, so simplifying in the first brackets. What's e to the 0? 1 minus e to the negative 2 is just ugly, and that's the way it is. Minus 2 when you distribute the negative. Okay, next guy. E squared is ugly. Just deal with it. Minus 2, and minus e to the 0 is minus 1. Yay? That's negative. The first bracket comes out totally to be negative 1 minus e to the negative 2. The second is e squared minus 3. So our final answer should have 3 terms. What's the total of the normal old constant numbers? Negative 2. Do we agree? Okay, negative 2. What's the total of the negative exponent e term? Plus e to the negative 2 and plus e squared. Is that positive? Better be positive. It is positive. E squared alone is more than enough to overcome the negative 2. All right, that's a typical problem. Are you with me so far? Okay. There are several cases where you could get 2 areas. Let's look at another one here. If I said find the area enclosed by y equals root x, y equals negative x plus 6 in the x-axis, then a picture is handy. So give me 3 points on the square root of x. 0, 0, 1, 1, 2, 4, 4, 2. 4, 2. Okay? 3, 4, 5, 6. All right? Negative x plus 6 is so here's the square root graph. Negative x plus 6 is a line that goes down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. The scale is tolerable. But they should meet at 4, 2. Follow? Now, if I look at the area enclosed by y equals square root of x, y equals negative x plus 6, and the x-axis, am I looking at here, region A, or here, region B? Region B. Why? This is the x-axis. Now, you need to read very carefully here because there will be other problems tomorrow, for example, where we will be finding region A. That would be enclosed by the 2 curves in the y-axis. Read very carefully so you don't find the totally wrong error here, all right? So we're finding region B. Okay, cool. Now, will I need to do any negating? No, because there are going to be positive y's and positive x's, yeah? So I'm good there. what is the integral I'm going to use to find b? From 0 to 4, okay. Actually, let's leave the limits. What should I put in the limit? Root x or the line? Root x, it seems like I'm getting rectangles that have a height of root x here until there, and then I'm starting to get rectangles with a totally different height. And so that's why we need 2x, okay? So we're going to need 1 for the root region and 1 for the line region. Negative x plus 6. Now, I graphed it and made a nice problem that looks like the intersection point, but we could verify the intersection point by saying, where does root x equal negative x plus 6? Wouldn't be much fun, but it is x squared equal negative x plus 6. We could solve this, and we'd probably get 2 solutions. One is for the bogus, not really a bottom parabola here. But this is sometimes going to be necessary. We'll talk more about that tomorrow. For now, we'll let it go. Okay? So, the picture tells us the limits of integration. The root, where are the values? Do they go from 0 to 6, 0 to 2, 0 to 4, what? 0 to 4 is where the square root region is. And the line region, what are the left and right limits of that? 4 to 6, excellent. Okay, so here we go. Anti-differentiating. What is the antiderivative of root x? 2/3 x to the 3/2. Remember, it's power rule for integrals, so you raise the power by 1 and divide by the new. But dividing by 3/2 is the same as 2/3 out front. Cool. From 0 to 4. Plus, what is the antiderivative of negative x? To the first. Power rule, raise the power, divide by the new. Negative x squared over 2. And what's the antiderivative of 6 with respect to x? 6x from 4 to 6. You following me? Okay? 2/3 of 4 to the 3/2 minus 0 plus, this one's going to be a little longer here. So this is negative 36 over 2 plus 36 when I put in 6. And when I put in 4, I get negative 16 over 2 plus 24. Oui, oui? Oui, oui. Okay, so what is 4 to the 3/2? 4 to the 1/2 is 2, and then cubed is 8. Times 2 is 16 over 3. Do you agree with that? Ladies in the back row, you down? Okay, cool. Plus, what do we got over here? Let's go with, what's negative 36/2? 2. Negative 18 plus 36 minus, what's negative 16/2? Negative 8 plus 24. 16/3 plus, what's 36 minus 18? 18. What's 24 minus 8? 16. And 18 minus 16 is 2. What's 16/3 plus 2? 22. Okay, total area 22/3. Is this going okay so far? All right. You try one. Find the area enclosed by this curve in the x-axis. Feel free to work it out with your math amigos. I'll throw you a bone and give you distributed form as well. That should take you about 5 minutes. It is no calculator. Go. How we doing? A lot of algebra that, yeah? And arithmetic? That's part of the problem, one you definitely need practice with. If you got a negative, you did it wrong. So the second region, did you put the negative outside or did you distribute it inside? Outside. Okay. You just model that, so I guess that's logical. Okay. No? Is that what you got? No. Where's Belmonte? Where's Sam? Abby, what'd you get?
Yeah.
37 twelfths?
Yeah.
How?
So if you just take this 2 to the 4th, and you cancel, it's supposed to be negative. Because it's negative 2 to the 4th, which is positive.
This is positive,
Yeah.
so these should not be.
So those should cancel.
I got you. You're right. Okay, so, what do we got there? So 7/3 minus 1/4 plus 1, something like that. So 28 minus 3 plus 12, and what did you say? Something like 37/12? Excellent. Well done. Okay. Let's try one where the graph is completely unknown. That does make things a little more complicated, but it's all good. You have to be solid on your game, okay? It says find the area enclosed by the x-axis and. The big question is there a region above and below? Above, below, one region? Two? Two? All that's, gosh, I don't know. I don't know this graph. What should I do? Well, even if you don't know the graph, you can still do this by saying, well, all these ideas, region above or below, to know if there's region above or below, you really need to know, does it cross the x-axis, yeah? That helps you get at all those questions. Is it above? Is it below? Does it cross? Is it 2? Is it 1? So let's set x to the 1/2 minus x to the 3/2 equal to 0 and see what's what. What would you do? Maybe I would do this. Maybe that's a little better here. What would you do then? Factor out a root x. When you do here, what's left? 1, and when you do here, what's left? X. And so it has zeros at 0 and 1. Excellent. All right. So it seems like it is crossing over from 0 to 1, or at least hitting the axis. Maybe it doesn't cross over. I don't know. Maybe it bumps it. I don't know. Who's to say? What about before that, like at 1/2? Is this positive or negative? Maybe this is the easiest place to look because it's factored. At 1/2 of an x, is that positive or negative? Positive. And at 2 or 3 or 4, positive or negative? Negative. So it looks something like it's positive before 1 and negative after. All right, now we're rolling. We can say the area should be twofold. 1 from where to where? 0 to 1 of negated curve or normal curve? Normal curve, so we would integrate x to the 1/2 minus x to the 3/2. And the other one, that needs to be negated, and it goes from 1 to 4. All right. And so the antiderivative of x to the 1/2 is 2/3 x to the 3/2 minus the antiderivative of x to the 3/2 is 2/5 x to the 5/2 from 0 to 1 minus same antiderivatives here. That's the beauty of not sending in the negative, then the antiderivatives are the same. All right, so when I put 1 in, what do I get? 2/3 minus 2/5, and when I put in 0, I do get 0, but always look. 2/4 I get, or sorry, when I put in 4, I get 2/3 times 4 to the 3/2 minus 2/5 times 4 to the 5/2 minus, when I put in 1, 2/3 minus 2/5. A lot of parentheses and brackets there. You gotta be careful. You gotta be meticulous. All right, are we cool? I think I'm gonna hold off on getting a common denominator because maybe down the line I'll get some little action from the 2/3. Maybe not. I don't know. But I'm just gonna leave these 2/3 and 2/5 and just drop the brackets on the first part altogether. You cool? I'm gonna fight the temptation to do too much at once, and at the back end I'm gonna go a little slower. What's 2/3 of 4 to the 3 halves? What's 4 to the 3 halves? 8 times 2? 16/3. Minus, what's 4 to the 5 halves? 32 times 2/5. 64/5. Minus 2/3 if I distribute the negative, and plus 2/5 if I distribute the negative. Let's do a little more of dumping the parentheses, and then I'll combine like terms as much as possible. So minus, or do you want to simplify the thirds and the fifths in here first and then drop the brackets? All right, let's simplify inside. How many total thirds? 14/3. Are you with me? Okay, and the total fifths? 62/5. All right. So what is 2/3 minus 14/3? Negative 12/3. That's already starting to scare me a little bit, but we'll hopefully the fifths will cancel it out or over muscle them. What about negative 2/5 minus negative 62/5? Positive 60/5. All right. I think those will come out clean. Negative 12/3 is surely negative 5. 60/5 is 12, and our area is positive. Thankfully, it is 8. All right. Let's try one with a calculator, and then we'll call it good. So get out a calculator, please, and throw that calculator into your graph. X cubed minus 5x squared plus x plus 1. Come on, baby. Grow. Oh, forget it. X cubed minus 5x squared. Plus x plus 2. Thank you. Plus 1. Plus x plus 1. Okay. So, getting a feel for the graph. What do you reckon I'm going to need to do now? Got that? I agree. That's a good call. You're right. Graph it. Then what? Integral. Okay. The minute you write the integral sign, then what are you going to write there? The balance. That means you'll leave the zeros. Okay. So, would you find the zeros, and we're going to be careful to store them because rounding errors is very much in a factor here. So, when I say 0, that first zero is between -1 and 0. You could scroll around, or you could just type in -1 for the lower bound and 0 for the upper bound. And the first zero is -0.348. Yeah? Are you with me? Store that, please. Store that to A. And then maybe move it out of the way. Okay? Do you have that first zero stored? Yes? Find the next zero. Between 0 and 1, it looks like. Did you get negative positive 0.6048? So, okay, so you just click on it, hit store, then just hit enter. Yes, I want to store it, and it should allow you to call it B. I'll do that one more time for the last one. Find the last zero. Okay, which seems to be between 1, 2, 3, 4, and 5, or whatever, 4 and 6. Did you get 4.74483? Hi. Thanks. So I'll do this with my trusty pointer. I'm gonna go to that and just click the center of your scratch pad, then go to our trackpad, then hit vars, hit enter. When it says, do you want to store the variable, say yes, and then call it whatever you want. C. Enter. You have your 3 zeros stored. Okay. All right. So we're going to need to communicate what we're going to do here. So the first region is negative 0.348. The AP test requires you to show 3 decimals. Is that 3 decimals everywhere in your work or just the final answer? Everywhere. Yeah, anywhere where they look for a point, they look for 3. And so do you have to put 3 there? Yeah, you do. Okay. The other is 0.604. For that, are we going to use normal F or opposite F? Normal F. Do I have to rewrite the whole problem on a calculator problem, or can I just say F of X? You can just call it F of X. Please save your time on the AP test. Don't write that whole thing and then make the possibility of copy error. Just call it F of X. What about for region 2? Normal F or opposite F? Opposite of F. And from 0.604, where we left off, to the right bound, which was 4.744. Okay? Now, that is the work expected on a calculator part. You need to say, hey, this is the integral stuff I did, but now we're going to have the calculator do the evaluating the integral. So, calling up the integral, how do I call up a definite integral? Shift plus, the first region is from what stored values now? A to B, A to B of, and we can just call up our function in the vars, function of x dx. We could find them separately, but I just don't see the point. Let's just say minus, shift plus, and roll right into the next calculation. From where to where? B to C. If you're thinking, should I do them separately because we'll get some partial credit if I do one right? No, you won't. Okay, so just do it all at once. Dx, and I'm getting 36.4406. How about you? 36.4406. So you could go 440 or 441, or give me more decimals. So that's fine too. But that's your answer. It's tempting for students to put units on that. I understand. But don't worry about the units. We'll talk more about that later. Are we good? Okay. That is the lesson. Here we go. Can we at least finish? Maybe. I might have to end up grading this myself. Where did we leave off on set 80, 50? It was titled 55B, but it should have been 57B. Did we get through this one? No? Yeah. E. Okay. So our candidates were the endpoints of -2 and 2, yes? Okay, so G at -3, did we find it or not yet? Shucks. 1 plus the integral from, what is G defined as? From 0 to -3 of F. Sweet. Okie dokie. The first thing we talked about was switching the limits. And so we could go there. Then just putting the negative out front and getting straight the algebra. Isn't the area from 0 to -3 a positive triangle and a negative triangle? Okay, positive triangle, negative triangle. For the little upper triangle, what's the base and height? 1 and 1. For the lower triangle, what's the base and height? 2 and 2. So did you get something like 1 minus negative 3 halves? So 5 halves? Did you get that? Okay. G of negative 2, I think we already found, didn't we? In part C. G of negative 2 was 3. Which of those is bigger? 3 is bigger than 2.5. So far, it's winning the absolute max contest. Let's see what else we got. G of 0 is not an option. I don't know why I'm finding 0. G at, what's the next critical number? G at 2?
Yeah.
G at 2 is 1 plus the integral from 0 to 2 of f. 1 plus, that one's a bit of a stinker. Here is what I'm trying to find. Now you have, this is one of the hardest ones. You have two things going on. First of all, you have to consider that that region is below, okay? So you need to take the opposite of the region. And then you have to be on your geometry gauge. How would you find that shaded region? Rectangle minus quarter circle. So base height minus quarter circle. 1 minus, what's the rectangle base and height? 2 by 2? Okay, so that's 4. And what's the radius of the circle? 2. So that's 4 pi over 4. So that's pi. So that, when it's all said and done, is negative 3 plus pi. That's about 0.14. If I were thinking of that in the decimal point. You follow? Last but not least, G at 4. Is that right?
Yeah.
Okay. So that's 1 plus 0 to 4 of f. It's going to be very similar here in that you've got some negative area action. But the geometry now of the shaded region is going to be a rectangle minus not a quarter circle, but a half circle. The rectangle will be different and the circle part will be different. Half circle. This really is some ugly geometry. What's the rectangle now? It's not 2 by 2 anymore. Now it's 2 by 4. And this should be over 2, not 4. So that then comes out to be what? 2 pi for the half circle? Yeah? Are you with me? Okay, so negative 7 plus 2 pi. What's pi about? 3.14 times 2?
6.2.
6.2-ish, 6.28, and negative 7 then would be about negative 0.7, yeah? Do you agree? Now, from those choices, we get to choose what's the absolute min and absolute max value of the function. What is the lowest y value of all of them? The negative 7 plus 2 pi is the least of all those. Do you agree?
Yes.
Okay, so absolute min is negative 7 plus 2 pi. The absolute max, what's the greatest of all those values? It is 3, yes? And boom, you're done. Okay, that was a humdinger. Let's go to, wow, this is a bad mixture of a lot of stuff to go over, but not a lot of question time here. I think what I guess I might have to do is at least put answers online tonight so you can check how you're doing here. And then maybe we can do some questions tomorrow on just the ones you need help on. How's that sound as a solution? All right, I will put solutions online tonight. Maybe with some work hinted at, but not all of it, so it's not a total copy fest. 58, how much straightforwardness is that? Is it pretty straightforward or no? Do you have questions? You weasel. Optimization, all right. Tomorrow, tell me this, 58 questions, what do you need me to put online tonight?
Separate rate.
One,
The separate rate.
the replacement, okay, got it, what else? 10, anything else you'll need a little hint on tonight to post? 21? Is that what I heard? Okay, so make sure that not only do you need tonight's homework, but look those over and I'll try and get you started there. Okay? Yes. Where'd you go? Kansas? That's right. Oh, really? It's, I mean, it's one of those schools that is what you mean. How did you like it? Yeah? Pretty wonderful. You never get a chance to go see a game. It's about the best sporting event there. Have a good day. Hi. How do you do? Super.
I'm very happy to see what I got all of
Yeah, you did really well. I was happy
So
for you.
happy.
Yeah, you earned it. You worked hard. Have a nice day. Hello. What's up?
Nothing much. I'm just gonna be gone Friday, so can I take the test tomorrow and Thursday?
Sounds good. I'll be ready for you.
Thank you.
You're welcome.
Is it
Have a
a long
good
one,
day.
do you know, or?
It is it's 2 pages printed back, 10 questions.
Oh, that's not bad at all.
Yeah, it doesn't look too bad. I don't know about the difficulty, but the length
yeah.
isn't
No,
bad.
this unit's tough.
Is it?
Yeah, it's so hard to learn online.
Yeah. It's hard to visualize this stuff anyway, but yeah, I hear you. Do your best.
Thanks.
Have a good day. All right, so I did together.
I do not like Are you finding new spots? I'm gonna get here early. We're gonna come straight from science class and build these.
I just wondered because I saw it under your desk at the time. Oh, yeah. I didn't know who was yours.
All right.
What are you gonna do about it?